Because of a sudden development, NASA's the Space Telescope James Webb has made a revolutionary finding that has left astronomers worldwide were astounded. This past week, the telescope revealed the universe's oldest known galaxy. However, it has recently discovered something much more. Imagine a massive black hole that is swiftly departing from its native galaxy at a startling 4 million miles per hour. This new discovery is important ramifications and has generated a lot of discussion and scientists' interest in space, enthusiasts in relation to its possible impacts on our understanding of the James Webb Space Universe. Launched alongside the telescope was the goal of investigating the initial galaxies across the cosmos, which has obtained stunning pictures of stars and galaxies dying out from the James Webb Telescope. What is it? After only a few 100 million years, we welcome you to join us as we explore the Big Bang. We discover more regarding these most recent insights from this amazing telescope. Kindly like and subscribe for further upgrades similar to this new finding that contradicts existing science models pertaining to black holes. Black holes are often thought of as enormous pressures that drag everything, incorporating illumination into their cores. But this recently found black hole seems to go against expectations. Instead of just taking in information and thinking lack of light, it seems to be creating new stars on an extensive, well-traveled route. Saw this trail of young people following it. Stars span an incredible 200,000. In the light years, the unusual. This black hole's behavior has perplexed researchers under the direction of Professor Peter and specialists in astronomy just published their discoveries in the Astrophysical Letters from the NASA Space Telescope Journal. Further backed these findings, indicating that this dark new star formation is triggered by holes when it cools gas via interaction. We're watching the effects behind the black hole's motion, and we're just getting started. Additionally, one NASA researcher has produced another noteworthy statement about the galaxy merger known as ARP-220 was also the James Webb Space captured. Examine this remarkable combination of one may see galaxies gleaming brilliantly amid the night sky's other galaxies. When two spiral galaxies collide, create a phenomena where the ARP-220 glows. The magnificent new picture is out, brightest in the spectrum of infrared light. Ideal candidate to be observed by the James Webb Space Telescope, categorized as a very bright galaxy infrared with a luminosity corresponding to 1 trillion suns above our galaxy, the Milky Way, which has a brightness of almost 10 billion suns, situated inside the Serpens ARP constellation. 220 is around 250 million light-years distant and is regarded as among the 3 closest galactic affects Earth. This galaxy is listed in the Atlas as item 220 of 700 million peculiar galaxies. 2 spiral galaxies collided years ago, causing a tremendous starburst formation. This explosion produced a space around 5,000 light-years in diameter, containing over 200 massive star clusters. Surprisingly, this little space contains everything of the gas in the Milky Way's earlier radio telescope observations discovered over 100 supernova remnants. The James is 500 light-years away. Additionally, Webb Space Telescope disclosed that the distance between the core galaxies is 1,200 light-years apart, each with a revolving star formation ring that releases powerful infrared light to create new pictures. Shows the merger from the telescope galaxies in extensive detail as well, emphasizing the weak tidal tails that stretch external to the union, suggestive of the attraction of gravity between the two. The orange and reddish galaxies, streaks and filaments are dispersed or ionized substance in ARP-220 is yet another astounding finding. Scientists were shocked when researchers found primordial galaxies that have been discovered. First, at the edge of the universe, there was doubt over their validity, with some people supposing that they may be neighboring galaxies masquerading as old ones. To confirm the results of the data was sent to scientists worldwide. The world was shocked to learn that according to Webb Space Telescope, the existence of ancient galaxies is confirmed by. Thanks to this groundbreaking telescope, we now possess the capacity to see the oldest estimates of galaxies ever seen by astronomers. That these galaxies' light has spent around 13.5 billion years traveling there, arrive on Earth, giving us a look of, in the distant history of the cosmos. The discovery of galaxies occurred when the universe was only getting started, offering vital information on the significance of this finding for science. Quick creation of the first generations. Spectroscopic data of galaxies demonstrates that at the extreme edge are these galaxies of the cosmos that we can see, some of which can be inaccessible to even this finding by the Hubble Space Telescope is crucial, as it backs one of the principal objectives of using the James Webb, using a space telescope to investigate the cosmos via light that has, for more than 13.5 billion years, the telescope's capacity to measure. It is distinguished by its intense red shifts, allowing astronomers to see the infrared range and start viewing early galaxies as soon as the thrill this discovery offers is tangible, as it symbolizes a substantial, significant development in the investigation of the universe and our comprehension of its development. The results have had a significant influence on our understanding of the cosmos and have prompted NASA to create ever more sophisticated telescopes to further examine the precision of our understanding of the Big Bang data from the FGS spectrometer on the Webb and close to. According to an infrared camera, 6 primeval galaxies are shown to severe red changes, indicating that the Webb is looking at them as they were 300 to 500 million years after the Big Bang. Without hefty components like carbon, this is astounding, as the cosmos is around 13.8 billion years old. Additionally, these early galaxies need a new evaluation of our comprehension of this finding has shown the early cosmos highlighted issues in the scientific community as it questions the existing model of cosmic inflation and the large bang hypothesis, which both include certain discrepancies, such opposing laws of thermodynamics and not providing adequate justifications for the elements that caused the Big Bang. In addition to the Space Telescope, James Webb has almost discovered galaxies that are as ancient as the Big Bang itself, which prompts inquiries about upcoming findings to anticipate what we believe to be true about the genesis of the universe. A theoretical physicist named Miyokaku has claimed that the identification of these, we are forced by older galaxies to review everything that we have learned on the genesis of the cosmos. These galaxies were previously believed to be younger and less evolved than the Milky Way, but new research suggests that we could be overlooking crucial information, since 6 galaxies discovered by the telescope were formed only a few hundred million years ago, with half of them existing today. Approximately 10 times the size of the Milky Way grows after the Big Bang, raising significant doubts regarding whether we currently accepted theories of cosmic genesis include precise. Kaku has said that the creation of a galaxy like this takes billions of years. Large young primordial galaxies like this are hard to find in the Milky Way. This finding might lead to extensive textbook modifications about the Space Telescope's findings regarding the universe's beginnings. Despite this, James Webb argues that our current knowledge of the Big Bang's effects on scientists is at a tipping point. NASA recently tweeted about revealing a galaxy cluster just 650 million years after the Big Bang is believed to have happened. Its discovery provides more evidence of a speeding galaxy, which is one of the oldest and most distant in history. Conclusion and outro: creation in the early universe much faster than first thoughts. The group consists of several ancient. It was assumed that these complex formations would have developed over billions of years due to the gravitational attraction of galaxies. Early galaxy clusters suggest that the Earth could have undergone a more rapid transformation then. Their existence supports the mounting evidence that the first 100 million years after the Big Bang were far more active and productive, according to accepted cosmological models. It took around 13 billion years for the light from the cluster to reach Earth, which is more than expected and allows scientists to study the cosmic conditions. Soon after its creation, scientists from MIRI can now analyze the cluster's characteristics with the use of Webb's advanced instruments, such as near-infrared cameras, or NIR cameras, and a mid-infrared device, such as its temperature, composition, and motion with unprecedented precision. These studies may provide light on the role that dark matter and energy played in the construction of the early universe's structure, the gravitational lensing phenomenon that was discovered in. This cluster also makes it easier for objects further away to grow behind it, creating a natural cosmic telescope that allows one to view much. The Webb extends throughout space and time. The capacity of telescopes to detect these primordial features has revolutionized our understanding of galaxies' early formation and sparked discussions about revising the universe's evolutionary timeline. While these models are still in use, some theories are still looking into other cosmic origin concepts, such as bouncing or cyclical universes, as potential explanations for these findings. The information on the internet is speculative, resolved cosmological arguments that are compelling enough to be reopened for a long period. We may expect more groundbreaking discoveries every time scientists around the world continue to analyze the telescope's data, as image and data gathering may hold the key to unlocking deeper truths about our origins and the workings of the universe as we learn more about the creation of the James Webb Space Telescope. The telescope is huge. Our greatest contribution to human ingenuity is a keen look into the distant past, and we are effectively seeing the brilliance of adding to our own cosmic history explosion when we gaze into the vacuum of space. Another intriguing aspect of the mystery. After reviewing the data, astronomers concluded that this is anticipated to. The new cluster will develop into a massive cluster in the end. Comparable to Coma A656, this discovery is very significant since it is located in a region of a galaxy that is rapidly developing, made possible by the space James Webb. The velocities of the 7 galaxies may now be determined by researchers using telescopes. Query allowing them to demonstrate. They are bound together in a. The protocluster should include this. Viewpoint. NASA scientists compared small droplets in many rivers to massive, distant galaxies, which will eventually join together to clearly display a powerful river that we used to. Theories about the Big Bang may not agree. Using the information that is now available, more data from the Internet telescope may soon provide proof that either confirms or refutes these Big Bang ideas. Although the reason is unknown, it can be entirely different. The rest of the story may have to wait. Conclusions, but the answers could be closer than we think. What do you think about these findings? Please leave them in the space provided for comments below. Thank you, and I'll see you in the next video. Space James Webb. The scientific community is eager to anticipate any revelations that might alter our understanding of the cosmos with each new discovery, and telescopes for observation continue to be a creative invention of science. The possibilities of what we thought might be given to us are being expanded by the telescope. A thorough examination of the cosmos and accuracy, its ability to perceive the. Astronomers are able to piece together the early history of the cosmos by examining the weakest and most distant galaxies, giving a description of what transpired. These findings date back billions of years. Crucial because they provide challenging long-term theories about the formation and evolution of galaxies. If these newly found galaxies are really as ancient as they seem, it poses significant questions regarding the rate at which galaxies might evolve and transform. The creation of massive, developed galaxies. There may have been unknown processes at work shortly after the Big Bang that we had not yet fully understood. Webb James, the space telescope's ability to capture such in-depth understanding is likely to lead to other discoveries in the next months and years to come, along with the knowledge acquired by researching these old galaxies. The information will assist scientists in improving their simulations of cosmic development by looking at these early galaxies' properties. researchers anticipate obtaining a better comprehension of how the cosmos changed from its tumultuous beginnings to the more ordered shape that we see. The part black holes play in this today procedure, particularly with regard to how they influenced galactic and star formation. Evolution continues to be a primary theme of examine. Yet another intriguing facet of the Space Telescope James Webb's observations is its capacity for research, star formation in these old galaxies, as well as revealing black flaws that seem to go against the. Additionally, a telescope has located areas where the birth of stars occurs at a astounding pace, with which certain areas of intense star formation may provide useful indications about how the first stars in the creation of the cosmos and what circumstances were required for their birth. As scientists continue to examine information gathered by the James Webb Space Telescope, it is becoming evident that the findings that are being produced are only the starting. The telescope's unmatched sensitivity and sophisticated talents make it a priceless exploration tool. The most remote regions of space in the future, it is expected to disclose even further puzzles, from the start of galaxies to dark matter's characteristics and evil energies, as the findings so have already altered the way we comprehend the universe. The path is long. Scientists are only getting started. Only a small portion of what the Webb Space Telescope may unveil something new. As the telescope receives data, it will keep challenging established hypotheses that provide fresh perspectives and generating new conversations around the essential characteristics of the cosmos. The enthusiasm for these findings is not limited to scientists alone. Both the general public and space enthusiasts have been enthralled by the breathtaking pictures and innovative discoveries. According to James Webb Space Telescope, because of the telescope, there is a renewed enthusiasm for space travel and motivated a new crop of astronomers, visionaries, and scientists to gaze at as we marvel and be in awe of the night sky. We keep delving further into the depths of the James Webb. Is one thing that is guaranteed in space. A new chapter has been launched by Space Telescope in our endeavor to comprehend the cosmos. With every new finding, we get closer dealing with some of the most significant inquiries about the nature of reality, the origins of the universe and its destiny, of all of its contents. In conclusion, the findings from the James Webb, the Space Telescope, has significantly influence on our comprehension of the cosmos, from the first galaxies to massive black holes and supernovas that create new stars. The telescope is changing how we see the universe. As the mission advances, we might anticipate even further disclosures that will test our existing universe models and motivate future scientific generations to keep investigating the enormous mystery. Thank you for keeping up with this fascinating. Join us on this trip and check back for more James Webb Space Telescope upgrades. With its astounding discoveries, the telescope's findings mark the beginning of a new age of space travel, signifying a significant change in our comprehension of the cosmos. Its innovative style and sturdy capabilities enable astronomers will study galaxies in the distance, cosmic phenomena and star systems in hitherto unthinkable ways. This telescope has many uses than merely seeing as a gateway to the night sky, but also the ancient past provides a distinctive viewpoint on the evolution of the cosmos. Since its inception, one of the most exciting aspects of the James Webb, the capacity of the Space Telescope to look at things that are billions of light years away, enabling researchers to record pictures of galaxies in their natural state soon after the Big Bang, providing us with a glimpse of the early universe. Stages. The infrared vision of the telescope is particularly useful for identifying very old galaxies which are often too dim or far away to see with Additional telescopes for these observations provide important context for understanding the procedures that resulted in the development of the first stars and galaxies. As the universe is still being examined by the telescope's results are difficult to interpret several long-held scientific presumptions. For instance, the identification of galaxies arising so rapidly after the Big Bang implies that our existing theories of revisions to galaxy formation may be necessary. These results force us to reconsider how galaxies change and expand, and if unknown variables are impacting this procedure which we have not yet discovered.